Alright, welcome back, class. This is video 3 of section 6-2, Balancing Chemical Equations. You might want to start a little note section, a new note section on your notes. And just a word of advice, pay careful attention because this is important. Balancing chemical equations. The principle of conservation of mass means that the same number of atoms exists in the products as in the reactants. To describe a reaction accurately, a chemical equation must show the same number of each type of atom on both sides of the equation. Chemists say an equation is balanced when it accurately represents conservation of mass. How can you write a balanced chemical equation? Number 1. Write the equation. Suppose you want to write a balanced chemical equation for the reaction between hydrogen and oxygen that forms water. To begin, write the correct formulas for both the reactants and the products. And I think they did that right here. Here are the formulas. H2 for hydrogen gas, O2 for oxygen gas. Hydrogen and oxygen exist as diatomic molecules, not as single atomic molecules. And it equals H2O products. Place the reactants, H2 and O2, on the left side of the arrow, separated by plus signs. Then write the product, H2O, on the right side of the arrow. Moving up. Step 2. Count the atoms. Count the number of atoms on each element on each side of the equation. You find 2 atoms of oxygen in the reactants, but only 1 atom of oxygen in the product. Alright, so here's another picture. It's unbalanced. You see 2 hydrogens here and 2 hydrogens here. Okay, that makes sense. But there's 2 atoms of oxygen here and only 1 atom of oxygen here. It's unbalanced. How can you get the number of oxygen atoms on both sides to be the same? You cannot change the formula for water. Now that's really important. You cannot change the formula for water. A lot of people says, oh, well, Mr. Worley, why don't we just go ahead and come back up here and write a little 2 right here. But if you do that, this is not water. If you do that, it's hydrogen peroxide, which is poisonous if you drink it. Kill you till you're dead. You don't want that. So you can't change the formula of the product, or of water, because H2O2 is a formula for hydrogen peroxide, a completely different compound. So how can you show that mass is conserved? Dun dun dun. Go to next page, 198, please. Balance, continuing on, the number of oxygen atoms by writing the coefficient 2 for water. That's like saying 2 times H2O. Now, there are 2 oxygen atoms, 1 in each molecule of water. And so what they've done is they've added a coefficient. I'm going to circle the coefficient right here. You'll notice that the coefficient is not the subscript. The subscript is the little one here. Sub means under or little. Script means writing. So subscript is always a little writing underneath. Coefficient goes right before the molecule. So what this means is now you've got 2 hydrogen atoms, 2 oxygen atoms, and 2 oxygen atoms, 1, 2, and 4 hydrogen atoms, 1, 2, 3, 4. But is it balanced? Well, no, it's not balanced, because even though you've got 2 oxygen atoms, you still have 4 hydrogens on one side and 2 hydrogens on the other. Balancing the oxygen atoms throws off the hydrogen atoms. That makes sense. There are now 2 hydrogen atoms in the reactants and 4 in the product. How can you balance the hydrogen? Try doubling the number of hydrogen atoms on the left side of the equation by writing the coefficient 2 for hydrogen. Looks like they've done that. So 2H2 plus O2 equals 2H2O. Okay. Now, is it balanced? Look back and check. The equation is balanced. It tells you that there are 2 molecules of hydrogen react with 1 molecule of oxygen to yield 2 molecules of water. Count the atoms in the balanced equation again to see that the equation is correct. All right, so 1, 2, 3, 4. 1, 2, 3, 4. Makes sense. 2 oxygens, 2 oxygens. We're cool. All right. Let's read the math. Let's read the math problem here. Balancing chemical equations. Magnesium metal reacts with oxygen gas O2, forming magnesium oxide. To write a balanced equation for this reaction, first write the equation using the formulas of the reactants and products. Then count the number of atoms of each element. And say that's exactly what they did. First, they wrote the equation Mg plus O2 equals MgO. All right. Then they counted the atoms. Well, you got 1 magnesium, you got 2 oxygens, you got 1 magnesium over here and 1 oxygen over here. Okay, well, that's not quite right. 3, they use coefficients to balance the atoms. So magnesium has 1. They add a 2 to oxygen. So that makes there's a total of 4 oxygens then. So remember, 2 times 2 is 4. And then they add a 2 here to get 2 over here. But it's not quite balanced yet, so they decide to add 2 magnesium here to balance out the 2 here. And it looks good, kind of. Let's read. Balancing the equation for the reaction sodium metal with oh, never mind. So here's our example. Doesn't look right to me. Okay, yeah. So it looks like they were counting the atoms here. They counted them up, and they put the coefficients in the right place to make it balance. Looks good. All right, balancing the equation for the reaction of sodium metal with oxygen gas to form sodium oxide. Oh yeah, this looks like a good question. Good quiz question. Can you balance it out? Give it a shot. All right, please go to the next video.